Assalamu alaikum dear students. Bismillahirrahmanirrahim. Welcome back in lecture 36. Okay, this is session 5 and in this session we are basically analyzing the different determinate and indeterminate trusses. So we did basically 3 to 4 examples on truss analysis. You see that how we model different type of trusses. Now in this lecture I am basically selected some other types of trusses, and you can see the truss which I select there. In this lecture I will cover inshallah 4 to 3 examples, okay, and 3 examples I will give you as a homework, and I will try inshallah to cover 3 to 2 examples, okay. So this is a kind of truss. You see that the modeling of this truss is easy than the previous one, okay, because you see that first of all whenever we are trying to model the truss, we need to find out the grid lines and spacing. So this is x1, this is x2, this is x3, and this is x4, clear, and this is z1, okay, this is z2, okay, this is z3. You have to look you have to look at each and every joint, okay. If you have anywhere any joint, you have to calculate its x distance and its y distance from this origin point, okay. Without calculating its coordinates of that joint, you don't able to look at that joint, clear. So you need the coordinates, the x distances and z distances of each and every joint, clear. So therefore this is z3, and for this joint this is z4, clear. Now this is your, let's say this is your point A, this is your point B, this is your point C, and this is your point D. Now CD spacing is given, that is 8 feet. BC spacing is given, that is 8 feet. CD spacing is given, that is 8 feet, clear. So X spacing basically, or you can say horizontal spacing, is clear. The problem is only in vertical spacing, okay. So from Z1 to Z2 basically that spacing is given, that is 4 feet, okay, and from Z2 to Z3 the spacing is not given, but what I understand from the geometry of this truss, I think this distance will be 4 feet, clear, because this is approximately at the mid of this member, and the rest distance will be 4 feet as well, because if this is 4 feet, so deduct 4 from 8, you can get this is 4 feet. You can determine this distance as well, okay, you can determine, okay, that how you can determine this height. This height is basically determined from this angle. You need to determine this angle, okay. How you can determine this angle? This angle theta will be equals to tangent inverse equals to this perpendicular divided by this base, clear. This perpendicular divided by this base, clear. So your perpendicular is 4 plus 8, that is 12, and your base will be 8 plus 8 plus 8, that is 24. So you will get this angle, and then by using this angle, okay, you will find out this triangle, this height, clear. How you can get it? This line is inclined, and this line is making an angle of theta with the horizontal. So you pick this triangle, okay, you pick this triangle and draw it separately. Assume this is y, okay, and this distance is basically, you know, uh, this distance is basically theta. So you see that this is this triangle G F, and let's say this is point A. GFA is formed. Now you can determine this base from the lower side, from the downward side, that is 8 feet. Clear? Because this 8 feet, these two lines are perpendicular, so therefore this distance will be 8 feet. So if you will use your trigonometry, you can determine that y equals to because you can use tangent, okay. So tangent theta equals to perpendicular divided by this distance. So you know, add into tangent theta, okay, add into tangent theta, you can get the value of y, and I think it will be equals to 4 feet. You make practice on it, okay. You can calculate theta from this one, and if I do this practice, if I tangent, I get this angle equals to 26.56, and then multiply it with 8. Sorry, 8 multiplied by tangent 26.56, you will get 3.99. So this is 4 feet. So 4 feet is confirmed. This is now, I already mentioned you in previous lecture, these distances is basically depend on your imagination, your level of understanding, okay. At the first glance, basically I guess that this value will be equals to 4 feet, because this is at the right mid point of this number, okay. So therefore I suggest that this will be 4 feet. So from calculation I proved that this is 4 feet. Clear? Now we model it and let's see what will be the results. Units are kep feet. Clear? So you must need to convert the units to kep feet. We can use this one as well as we can use this one. Let's say we're using this one. Clear? In x direction we have how much? 1 2 3 4, and in z direction we have 4. Clear? So 4 we don't need, and in this we have also 4. Spacing in x direction, that is 8, we don't need this one, and in z direction we have 4 feet. Clear? Four feet. Clear? Now these are the distances. Clear? So in z direction we have 4 feet, okay. So let's see what will be the grid lines. These are the grid lines, okay, and now we need to draw the truss, okay. So this is the first node, this is the last node, this one. Clear? We have okay, we have this one, this one, this one, this one. Clear? We have again this one, and this one. Sketch, then again Clear? So this is, I think so, our required truss. Okay, so I think so it is completed. We have this one, vertical, and this one. Clear? So I think we're done here. Now we will assume the we assign basically the joints. This is hinge and this is ruler. Clear? So this is hinge. Okay, this is hinge. Okay, and this is a ruler. Okay, now we have loading. The loadings are vertical. Okay, at this joint and this joint we have two caps. Joint loads, forces, make sure this is equals to 0. Okay, okay, and in z direction we have -2 cap feet. Okay, and there we have 1.5 cap. Clear? -1.5 cap. So this is how we model the joint, assign the joints and assign the loads. Clear? Now we will in position to analyze the truss. Model do not run now, and this is example number 40, I think so 50. This is example number 50. Clear? Save it, and these are the results. Clear? So you can check the result. X equals to 0, no inclined thrust. AY equals to 0. These are the reactions. I think so. The reactions are, you can calculate the reactions. Okay, you have 2 and you have 3.50. Okay, you have 3.50. So the next reaction is D point. Clear? So basically, if you want to check some of the joint members forces, let's say EF. So where we have EF, ED, we have EF. DC equals to 0. Okay, so DC, this one equals to 0. Let's see, we check it. Axial. Okay, so you see that DC, this one 0.15 almost equals to 0. Okay, and let's see, we will check it. AB is basically this one, that is 4, and this one is 4.47. so you can see that this is approximately equals to which is close. Okay, 4.7 or 4.01, and this one is 3.54, which is approximately equals to 3.54. Clear? So basically this is the approach, and the same approach basically as we previously adopted for the inclined truss. So this is also same like that truss basically. And now the next example is that you can compare, you can do your own practice. I think you can get close results than me. Okay, it is totally depends upon your modeling the member truss. Okay, if you accurately model the member, you can get accurate results. Clear? So the next example is this one. This example is simple. I don't practice it. Okay, I suggest that you people will do the practice. Okay, basically yes, there is a point load and the value is given, that is at kilonewton. Okay, and you see that you can use the 2D truss model. That is a simple. You have two divisions and the division length is 4 meter, and the height is basically you will determine it from trigonometry. How you can determine the height? It is simple. You can easily calculate. You just need to draw a perpendicular. Okay, you just need to draw a perpendicular from this point. Okay, you just need to draw, or you can need to connect basically this the middle of this 4 with this joint. Okay, so this distance will now equals to 2 meters, sorry. And now by using the trigonometry you will determine this height. So that will be your truss height. So you can easily model this truss by using 2D truss model. Assign this as a hinge and assign this as a ruler support and apply this loading. So when I practice this example, I get accurate results. Okay, these results can be achieved. Clear? So you do the practice by your own and compare the results with these answers. Clear? So this one is same. Okay, and now you cannot do this example on yourself. This is, the member forces are given, you have to determine this force P. Okay, so okay, now this is the example. Inshallah I will try it. Okay, right now, that what will be the results. Okay, for of this example. Okay, so let us try it by using 2D truss model, because it is easy to develop this kind of truss on using that template. Clear? So we have 1 2 3 divisions. The division lengths are 12 feet, and you have only height is 9 feet, but you need to rotate this hinge support by an angle of equals to 30 degrees. So let's see, we will try it. Clear? The units are in cap feet. Clear? So we are in cap feet. We use this one 2D. We have 3 divisions. Division lengths are 12 feet and the height is 9 foot. Clear? Okay, remove this one and make sure you will be in XY plane. Clear? Now we develop our required truss within the geometry of those grid lines. So we have to connect 12 okay, the inclined line. Okay, make sure that this is 6 feet and this is 6 feet. So we need to draw an inclined line from this point to this one. Okay, and then from this point to this point. Clear? And then we need to draw a vertical line there. Okay, and then an inclined line there. Clear? So we don't need this member, we don't need this member. Okay, so delete it. Okay, we don't need this one. Clear? And now complete your truss. This one, and this one. This is our required truss. Clear? You can see that this will be our required truss. Okay, now we will assign the joints. So this joint is basically, there will be no joint. So okay, there we need a hinge support, and I think so there we need a ruler support. So this is a ruler support. Okay, this is a ruler support. We need to rotate this support by an angle of 30 degree. Rotating this joint about y-axis in an anti-clockwise direction with an angle of minus 30 degree. Okay, we need to apply now loading. We have two kept at free end and out one direction. Joint load, make sure this is 0. Okay, modify, okay, and in z direction we need to apply a load of 2 kep, and at these 2 points we need a load of minus 4 kep. Clear? So this is the way that how we will develop or model our truss, and how we will assign the joints and how we rotate it. Okay, now we analyze. Model do not run. Okay, save the project. This is example number 51. Save it and see the results. Clear? These are the results. We have only one member force, and that member force is basically determine the force in each member. So in each member we see that dy, okay, this dy equals to 1 kef and dx and by equals to 9. So you can check the reactions as well, but let's see, we will check it that whether we get this value or not. AF force is 3.33 and AB force is 2.67. So let's see, we get 3.17, so that is correct, and we get also 2.57, and that will be 2.67. okay, so our results are basically close. Let's see, check the reactions. Okay, this is 9, these are inclined. Okay, these are inclined forces, so 0.87 is roundabout equals to 1, and 0.57 you can see that that is basically 0. It is considered to be 0. Okay, so this is 0.87. okay, so this is how we can model a truss and how we can get accurate results. Again, I mention you that whenever you are modeling your truss, model, first of all you need to draw that truss on your paper. Then you write down your spacing clearly. Okay, accurately calculate the values using by your calculators. Round your digits to 5 to 6 points. Okay, so these are the results. So these are the results. You can compare your results with these. Okay, so you must need to draw the truss sketch on a clear paper and draw the spacing, write down. Okay, and properly calculate the distances. Okay, by using your calculators, and then model it. So I assure you that you will be get 100% accurate results. Clear? I gave you this example as a your homework assignment. Okay, so this is a little bit tricky for you people. Okay, you can model this by using your 2D template. It is easy, but at you have to develop. If I explain you this example, okay, so you have division 1, 2, 3, 4 division, equal spacing, that is 10 feet. So divisions are clear. Now the heights are basically a little bit you needs a little bit work. Okay, you have to calculate this angle. Okay, and how you can calculate this angle? This angle can be obtained by using this triangle. Okay, this large size triangle. Okay, this is your perpendicular, okay, and this will be your base. Clear? So 10 plus 10 plus 10, that will be 30. So this angle will be tangent inverse 12 divided by 30. Okay, so you will get this angle. Okay, this angle will be this angle will be, this is 12, this is 30, and this is angle will be equals to tangent inverse 12 by 30. So once you get this angle, then you select this small triangle. Okay, then you select the small triangle. Okay, and you will determine this height x. Okay, this height y. And how you can get it? You have this angle theta and you have this base 10 feet. So by using trigonometry you will determine this height y, and that will be your spacing between z1 and z2. This y will be your spacing between z1 and z2. Then you need to determine this height, and then you need to determine, I think from the geometry I can say that this height will be constant as there and as there. Okay, this the heights will be also will be constant. Clear? So you make practice. Okay, to determine this height you need to select, okay, you need to select this large size triangle. Clear? This large size triangle, you need to select this one, determine that height y, okay, and then deduct this height to get this one. Okay, from this large, let's say this is y2 and let's say this is y1. So this distance will be y2 minus y1. Clear? And it will be approximately, I think so, from the geometry I can say that this height will be equals to this one. So this is the way that how we can calculate the spacing. Okay, and then by using grid spacing, okay, edit. Once you develop your model, then edit grid data, and in spacing you can insert these values. Okay, and you will develop your required truss. So I think this is enough in present lecture. See you in next lecture. Please share your comments, your questions, your suggestions on my channel. Watch the channel and enjoy. Thank you.